Good morning, guys. And today our topic is electrical machine part. First, in this your basic electrical, if you go for your last module, and then you can see there is some transformer, DC machine, etc. So for the electrical engineering and the department of electrical, machine is a vital part. There is a electrical department is uh, divided in so many uh, basic topics, and within this, machine is a very vital thing because throughout this era you can see there are lots of electrical machines are there. So what is a machine? You all know the machine means this is a device. You can see this is a device which can convert which can convert a electrical energy into a mechanical energy. That is called the electrical machine. Okay, so please mute yourself. Those who are some sounds are coming, mute yourself. So in this electrical machine, especially we are concerned with these things that electrical energy converted into a mechanical energy, then this is we are called this is the electrical machine. But all time this is not required that the electrical energy converted into the mechanical energy. Sometimes in machines there is the electrical energy is converted into a mechanical energy or any other form of this energy and then again convert into a electrical energy. So this type of things is called the static machine, that is the transformer. Okay, and this type of machine is a rotating type machine, rotating type machine, that is motor. Okay, so from these things we can understand what is a machine. Machine is a device is that convert one form of energy into another form of energy. But you're in concern of the electrical engineering, then we are generally talking with electrical energy converted into the mechanical energy, or sometimes electrical energy converted into the again another form of electrical energy. Okay, so this is the call of machine. And what is the if we we reverse it means if we apply some mechanical energy into an electrical energy, then what is this called? This is called the generator. Okay, so in generator there we are using, this is maybe hydro hydro energy, this is hydroelectric energy, it may be wind turbine, this is wind energy, it may be temperature means thermal, then we can get the electrical energy. And there is so many form, that is another so many form that is not called the conventional and non-conventional. Conventional means just the solar, etc. Okay, and some tidal. Okay, but non-conventional, which is not usually occurred in our practice, that is called geothermal. You can see it may be your ocean tide, etc. This type of energy also applied to convert this form of energy into the electrical energy. This is coming to the non-conventional sources, and some renewable energy, and these all are coming from just 1 minute. So guys, uh, look, just like this. This is all are coming from. This is all are coming from two type of sources. There is the all are renewable energy. This all are coming renewable. In this renewable, there is two parts. First one is conventional and another is non-conventional. Okay, so from this conventional, that is solar, wind, this type of energy are coming, and this non-conventional, that is no, coal is totally different. This is also coming from conventional. Conventional means this type of things are used in general way, and we are habituated with this. That is called conventional. And non-conventional is it is not in the general purpose. It is several times or very few times it is used, not regular purpose. Geothermal, ocean tide, etc. And coal, also coal, fuel, fossil fuels, and others, that is hydroelectric, that is also conventional. But this is not the renewable energy. This green color is undercome the renewable energy. Okay, and non-renewable energy, non-renewable, that is, and the red color, that is coming. Look, fossil fuel means coal, and it is also come petroleum. Okay, this is non-renewable. Okay, and within this conventional, look, solar, hydro. So in this way we are differentiating the source of energy, and this source of energy is converted into the electrical energy that is called machine, which device convert this one form of energy into the another form of energy, that is called machine. Okay, so for the basic idea we can say, not only that you have to convert this any mechanical forces or mechanical energy to electrical energy. Sometimes some machines are there which is only convert electrical to electrical. So from this discussion you can get the idea, that is machine means there is a conversion of energy. Okay, but whenever we are going for the energy conversion, not only that, the one type of energy to another type of energy, it may be same. Just like one type of machine is there in your electrical course, that is convert electrical energy into, in between there is another form of magnetic energy, then again it is converted into the electrical energy. So this type of machine is called transformer. Okay, and so we can divide machine into two types. One is static machine, static, no rotating part is there. Another is rotating machine. Rotating machine. Okay. So static machine is transformer. Example is transformer. You can see this transformer is everywhere in our society, in our practice. And rotating machine is motor, generator, etc., actuator, etc. Okay, so through this basic, we will have to study the basic idea of transformer, basic idea of motor, generator DC motor, and basic idea of generator, or you may say this is the alternator, etc. Actuator parts and drive parts are the further higher studies, that is in instrumentation and other subject. So let's start the what is the concept of transformer. Okay, so first of all, what is the we're talking about the transformer. So whenever we go for the study, this is a technical study. So we have to go for a proper manner. Otherwise, I only going to the just lots of talking, and you can remember this thing. So whenever you get this word, then you have to ask this word what, why, and how. Okay, so it may be anyone. So what is transformer? What? Okay, then how it is working, that is called working principle. And then why? Okay, so whenever you get any topic in your world through this course, and through this 4 years course, the basic things is we have to remember this, not to just listen to this. I can say from my memory, but how could I remember this thing? Whenever you get this word, that is a transformer, today this is our topic, then just make a question that what is this, how this is work, and why this is work. Now one by one I will give you the answer, and then you can remember this thing. Transformer, from this word, this is transformer, we can realize this what it it does mean that this is something transformed. This is something transformed. That's why this is called transformer. What is this? Which things is this transformer? So transformer is a device. Transformer is a device that is transform electrical energy into another form of electrical energy, but in different voltage. You have seen in your society that is some lamp post is there and some there is some transformer. So some high voltage, low voltage, you have just listened it. So transformer is a device which can transform one type of energy into the another type of energy. But which type of energy? This is also a electrical energy. This is also electrical energy. In your room or in your maybe in your society, you have seen in this pillar mounted transformer. There is a transformer is there. Something is uh, just like the insulator is there. There is some handle type things is there to on and off, and then some power line is going to your house. So this is the transformer, and from upper side it is transforming. Actually what happens, we are getting 11 kV voltage, but we are using only 220 voltage. So it is transforming energy, but it will just step down this voltage, because 11 kV voltage is very high for our domestic purpose, but we are using only 220 volt energy. So what we need this 11 kV into a 220 kV 20 volt. So we need a transformer. This is called the step down transformer. So from these things, if high voltage to if a device or the transformer convert a high voltage to the low voltage, then this is called step down. Step down transformer. And if anything is converting from low voltage to the high voltage, I am just giving you the alphabetic high and low, not saying that what amount of voltage is there, what amount of voltage is converted. It is in your upper semester study. Just going on these basics, that if the low voltage, you can see the this V is very small and this V is very high. So this is the high voltage, and this is the low voltage. So then it is called step down, step up transformer. Okay, step up transformer. So transformer is a device which can convert from electrical energy to the another form of electrical energy. Either it step up the voltage or step down. Okay. So if we give the 11 kVA voltage and we get the 220 voltage, just like your domestic purpose, then it is a step down transformer. So from this definition, we can get that if you ask this what to this transformer, then you can get that is if we apply some voltage, then transformer may be step up, step down, or sometimes it is doing that is this voltage level to the same voltage level. If you giving 220 voltage and you go also 220 voltage, so this is isolation transformer, means same transformer. Transformer, or it is called 1:1 transformer. Yes, someone is asking some. Hello, any question?
No, sir.
No, sir.
Many students are waiting, but I have no waiting room.
Some many students in the group are telling that they are unable.
But I have no waiting room here. Anyone can join. So,
Okay.
guys, could you understand the process of how to study the technical or the professional subject? I am not going for the conventional preparation. I am just talking about whenever you are how to study, how we can remember this thing, because there are lots of things is there. Every parts, every components you have to remember, you have to think of it so that you can apply uh, in your circuit or in your process. Not only this is, I am give you the example, this is what, how and why. It is also applicable for your mechanical, electrical, civil, or any stream. Whenever you get any topic, anything, just ask this question. If you ask this what to this transformer, whatever you get, then you can remember this. And if you write down this is became your definition, this is became your description. And how whenever you go for the how it is working, then it became your working principle. It became your working principle. Okay. And what it means, definition, description, everything. And why means it is application. So whenever you can get the all information about the definition, description, working principle, and the application, then you can complete your study and you can remember these things for this throughout your life. Okay, so transformer is a device which can step up, step down, or convert any energy into 1:1 format, at that is called the transformer. It is convert one form of the electrical energy to another form of the electrical energy. That is all. That is the what portion. We are giving the power, and we are also giving drawing the power. Now we are talking about the power. This small version. Power means power in your electrical. That is I means current. V, actually we're writing this V into I, not I into V, or anything you may. V into I in cos phi, because we are talking about AC. This is for the AC current. Okay, AC and DC will covered by Anil sir. This is actually in your syllabus. There is a two part we are dividing. Mr. Anil Kumar sir will take the first part, and CC will take the the half of this last part. Okay, so I am talking about the basic idea, and this is in this topic there is some motor transformer. It is coming, so that's why I am starting here. So this is for the AC, means you all are aware with this AC current, and if there is a DC, they are only V into I. This is for the DC. So in a transformer, we are converting the power from one format to another format. So the input power, whatever we are giving you, that is called the input power. Okay. And whatever we are drawing, that is called the output power. I'm drawing this over here. So so whenever we are giving some input power here, input power, and we are drawing, that is arrow is giving in the drawing, that is called output power. So in which portion we are giving the input power, this portion is called the primary section. And this section which is used for the drawing the power, that is called the secondary section or the secondary part. So in the input power, or we are not saying next time we are not talking about the input or the output. We are talking about the primary side and the secondary side, or the primary section or the secondary section. In this primary section, we also applied some AC. Look, transformer is for the AC. Okay, for now, just remember that is transformer is always used for the AC, not for DC. And in the DC we are sorry, in the secondary side we also get the output power. But what happens, this power is denoted as the P1, this power is denoted as the P2. For the transformer, the P1 equal to the P2. So you can get the definition over here, P1 equal to P2. So what is the, this is the power means P. So P is VI cos phi over here. So this is given as P1. So this is V1, I1 and cos phi. And here P2 is V2, I2 and cos phi. So from this equation, we can see this is V1, I1 and this is V2, I2. But here we never write the cos phi 1 and the cos phi 2, because here only this V1 I1, V2 I2 means voltage and current. Voltage and current in primary secondary are changing. That's why they are denoting in the I1 I2, V1 sorry, V2 V2 I2. But cos phi is same. So here the change is voltage and current, but cos phi means this is the power factor. Actually it is lets you know the later you know that is the cos phi is the power factor. It is coming from the frequency 2 pi f. Okay, and this is not change. So in this here electrical energy we are giving, this is P1 and we are getting the P2, but the change is there, voltage and current is changed. You can see input side V1 I1 we are giving, and output side or the secondary side we are getting V2 I2, but cos phi is same, so power factor is same. Just remember power factor or the frequency is unchanged. Okay, so this is all about the answer of the what, means the definition. Now we are going for the how it is working. Look, you can see this is the primary, this is the P1 side, we are giving the P1 power, and this is the secondary side, we are drawing the P2 power. Okay, so now my question is how, sorry. Okay. So whenever we are giving some current, that is current is flowing over there, current is going to this coil, just remember your ampere swimming rules. Whenever a current carrying conductor carrying a current, and if you put some magnetic needle, then magnetic needle will deflect it. Okay, why this is deflected? Why a magnet is deflected? Because whenever current is flowing through a current carrying conductor, then surrounding area there is a force of line is created, and this force of line is is occurs the deflection. So whenever current is flowing through this transformer wire, then each and every wire, because this is a coil, you can see this is a coil. So each and every wire is magnetic field is created. So magnetic field is created for the every turn. This is called one turn. This is called turn. And number of turn, how many number of turn is given? Look, the number of turn is different. Here red is very small, and this is green is very high. So whenever each and every conductor creates a magnetic field, then if you go for the vector sum 1 plus 1 1 plus 1, then you can get this line of force for this particular this side cross section. So everywhere they are creating some magnetic flux, and it has the direction also, because current is flowing over here, then it is the direction. It looks like a magnetic field. The arrowhead is denoted as the north pole, and the tail portion is denoted as the south pole. So whenever current is flowing through this coil, then also there is a create magnetic flux is created. But this magnetic flux it is going to pass through this core material. This material is called the core. Okay, it is made of iron and some alloys of iron, silicate iron. Okay, so it is flowing through the magnetic field. Whenever in a magnetic field we put some magnetic bar or anything, then it will induce and it became a magnet. So this is coming over here, and this is completing a circuit. This is called the magnetic circuit. And this core and this coil has the insulation. There is some insulation. There is no electrically connection is there. Just there through this insulating material, the magnet is not required any electrical connection or any touch. You may put any insulating material, maybe in your wood, cotton over here. If you put some magnet, north pole and south pole, and if you put any iron bar or ferromagnetic material, then it's also induced the opposite polarity. If you induce here, then it will induce this type of things. So here also, this is core material. This is made of iron ferromagnetic material, and through this core, it is a magnetic flux is completed its circuit. And whenever this circuit is coming, you can see the magnetic flux also coming over here through this coil, and this coil also insulated. Means there is no electrical connection. But what happens? This is the AC. In this AC, first half is in this direction, and second half is the opposite direction. Second half is the opposite direction. Okay. Again, because the 50 hertz cycle, well, again it is coming in this direction and in this direction. And not only that, the flux is not the static, not this type of static, means equal, because it is coming over here ultimately, then it is peak point, then it is again coming and going to there. So what happens here? Just remember the Faraday's law of electromagnetic induction. It is saying that if any current carrying conductor cutting the flux linkage, then an EMF is induced through this conductor. Means you can see this current carrying conductor is linkage or cutting the flux, because whenever it is flux is entering, it is cutting cutting this uh, cutting this area, and whenever it is change, means whenever its direction is changing, flux linkage is occur. Flux linkage is means there is not that the static flux is there. If you put some DC, then the static flux is there, no changes occur. And if you put some current in conductor, no EMF will induced. But EMF is induced whenever it is cutting, means change of flux nature you have to provide. Here is change of flux is nature is providing, because it is the one direction is going here. First it is look, flux density is going to gradually increase over here. It's the peak value, and it is decreasing again, it is the opposite direction. So flux linkage or flux cutting is occurred, not that a static things is occurred. So whenever a flux linkage is occurring, then what happens here, also an EMF is also produced. So what happens, we are providing some power. This power is an EMF, means this is also a power. Okay, means voltage, current, and magnetic sorry, power factor also there. So what happens, we are providing in this transformer, look, whatever is occurring, we are providing voltage, current, and cos phi. It will create, this is the electrical energy, it will create the magnetical energy or the magnetic energy. Then again this magnetic energy, due to the Faraday's law of electromagnetic induction, it is a phenomenon and described by scientist Faraday, and it will again, it is converted into the electrical energy, that is Vi cos phi. So electrical energy converted into the another form of same form of electrical energy, but through this period it is converted into the magnetical energy. So that's why transformer is also called the machine, because you have just listened that a machine is the just converting one form of energy to the another form of energy. But within this you can say, no sir, it is electrical energy to electrical energy, so why it is the machine in? But within meantime it is converted into the magnetic energy, again it is converted into the electrical energy. That's why it is called the machine. And you can understand how the transformer is working. First, whenever we are applying some voltage in voltage current cos phi, this is the power, then this power creates the current is, whenever current is flowing through this coil, then it will give some magnetic flux, and this magnetic flux started the linkage over there, flux linkage is there, and this secondary coil will occurred a flux linkage. Due to this flux linkage, means flux cutting of flux, then it is already an EMF is induced, just like a motor. Okay, so here another power we are getting. So we are getting this power. So this is the working principle of transformer. Look, this portion, this turn, number of turn is called the coil, and means this coil, this is coil, and this is the core. So transformer has generally two parts. One is core, that is made of ferromagnetic material, and another is coil. Okay, coil is made of copper generally. So there is a two coil, there is two part of coil. At first was the primary coil, and second one is the secondary coil. You can see this is the primary coil, this is the secondary coil, and this coil and core are insulated. But through this core, current is power is transferred by which? By magnetic flux. So magnetic flux is phi, it is unchanged. Okay, magnetic flux is unchanged. So guys, this is the working principle. And now, what is the requirement? How? I am giving the question of how. Okay, how it is working? Sorry, why? How it is completed, and why? Why? Why means you can